Hello, my name is Jamie, and today we're going to be talking about CadQuery Python Packaging, making your own library. The goal of the video is to show you how to make your own Python package that can be called in your CadQuery scripts. And the idea is you run through the tutorials, you start making objects, you get these scripts that have code in them, and you'd like to reuse that in other projects. So the Python packaging is a way to get code reuse and get the Python imports going. And let's just go into the example. So here I have a script, and I'll run it. So I'm importing CadQuery as CQ from CadQuery helper. This is a library that I made. Import shape. Here I'm calling shape.archPointed, and let's just set this. And what is this? This is arch. So here I'm calling shape arch pointed. We're assigning it to a variable. In this case, I'm applying a color to it, this light blue. Then we'll create a second arch, slightly smaller than the first one. Run it. So here are the two arches, and the idea is I'm going to cut out this interior arch from and leave the band effectively. So arch cut is exactly what I'm doing. This third instance, we're calling arch cut, arch 2. And so what that'll do is just leave the exterior portion, like so. But the code that actually calls this comes from a library called CadQuery helper. So let's just start in. To preface this, I wrote the script up. I haven't tested it. I haven't run through it as a demo yet, so there could be some learning as we go along. All right, so the prerequisites of this is that you have Python installed, you have pip installed, you have Git, virtual env wrapper, CadQuery, and CQ editor. If you're missing any of these or you're not sure, the previous videos that I've put up cover these topics. All right, some resources you should know about is setup tools. So this is going to set up the documentation for creating the library or package. We're going to make some new configuration, and this is the documentation for how you set up that configuration. Is the setup tools. All right, so an example plugin. So this is beyond what I have here. An example plugin that's out in the wild is there's Justin SDK CQ More. And so here, some example shapes that he's got going on, how to install it. So he's not using PyPy. Let's just look up it. At least not yet. And so PyPy, the Python package management, is where you can send your packages up. You can also just install directly locally, or you can also install directly via Git, which is kind of cool. So in this case, he made this is a package. This is an extension on CQ CadQuery, and here's some examples. So actually, any of these should be able to work. So if I go here, and I probably already have installed. Let's just take this stuff out. And then I may still want CadQuery in here. Let's do show object and just show object arch. Results. Okay. Okay. Cool. So in this case, this is using his extension on the work plane, which has definitely some additional features. Yeah, that's cool. All right. Meanwhile, so there's an example of a plugin that's directly extending, adding additional functionality. So some stuff he's adding is like he's got import STL files, which is something that CadQuery doesn't come with natively at the time of this video. All right, so this is an example plugin, and he's directly extending CadQuery. An example library, this one is one that I wrote, which is CadQuery Helper. This adds various shapes, shape primitives to the that I've written. Um, so example usage, we've already kind of gone over example usage, but this is the one I noted at the time I was writing the script up. So installation, again, I have shown the installer via Git. I haven't uploaded this to PyPy yet, primarily because I haven't finally decided what I want to name this library at the moment. So for now, it's just being installed via GitHub. All right. So how can we make our own library? And so let's just kind of go through the steps and get things up and running. And so I want to show these side by side at the moment. So I'm going to make my changes directly in this directory, but it could be literally anywhere. So let's just, it doesn't really matter where we make it. So what's the first step? First step is create a directory. This is arbitrary. You can come up with any name you want. In this case, we're going to call it cqlib. And so if you are considering putting it up on PyPy, when you start thinking of names for your packages, you want to look for names that aren't already used. Probably all lowercase and without dashes or underscores, although I believe you can get away with that. Spaces are out. So, and the whole conjecture is we're following the naming standard of doing an import. So we want the package to be named as something we can import. The top level name here, this name is arbitrary. You can name it anything, but when you actually name it further on down, when you start referencing it for what the package name is going to be, then the naming matters. So I tend to just follow the same standard for the root directory at the top. Okay, so we made a directory. We call it cqlib. That's why I wanted there. All right, so we'll do trickiness. So here's our cqlib directory. Next, we're going to create a source directory. Inside of here is going to go the name of our project. And the name, this directory represents directly what it's going to be referenced as. At least for the sake of the shortcuts. I'm sure you can name it something different and then in the packager give it an alias effectively, but um, we're just going very simple box standard at the moment. In this case, I'm going to create cylinder.py, and that should be bolded, so I got a problem with my markdown right there. Yeah, right there. Okay. Meanwhile, so we're going to create cylinder.py inside of cqlib. Going to pull this over here. And in cylinder.py, what we're going to do is we're going to import in CadQuery as CQ. We're going to find a cylinder. This is kind of a hello world example, right? I'm not particular about the contents of what this thing does or the particulars. This is just an easy way to get a script out there that we can show results from. Okay, copy. So create cylinder. And so what is this doing? Importing, making a cylinder, giving a basic radius, a basic height. We're going to grab a work plane, just call the pre-built-in cylinder, set the height and radius. It's not exciting. Um, but that's okay. Make init.py. Oh, that's off too. That's got to be bolded. Fascinating. With the following cylinder import cylinder. So in this directory, we're going to make init.py. And is it called? No, it's underscore. Oh, it messed it up. Okay, so the markdown messed that up. So underscore underscore init underscore underscore dot py. Let me fix that real quick. So yeah. So the markdown got confuzzled by that. Very confuzzled by that. I gotta do some character escaping in here. That's better. Okay. Bear with me a moment. Documentation woes. All right, so make init py with the following. Okay, so we have an init underscore underscore py. We're basically going to import the file we just made, if we can spell it correctly. Import dot cylinder. So why am I doing that? So what I'm setting up is effectively, turn this up, is effectively we're going to call import CQ lib, and then what we could do is so we could say from CQ lib import cylinder. The tricky bit is that if we want to call the method, because this isn't a class and because of how this is set up, if we wanted to call this, it gets a little awkward if we don't set up that init py. So if I want to call that code, I'd have to call cylinder.cylinder, right? It works, but it's a little bit cumbersome. So by setting up the init py, we can set a direct reference. So import cylinder. So from dot cylinder import cylinder. And so now the import changes from cylinder.cylinder to from cqlib import cylinder. And it becomes something like that, right? Um, so basically we took out a reference. And what that allows is still keeping the code highly compartmentalized. So you can have, your individual shapes or whatever you want, your individual files, and then define it in the init py how you want to reference it effectively. It gives you more control. Um, and it's totally optional. You don't necessarily you can get by without having an init an underscore underscore init.py file. Um, okay, so back to the steps. So from cylinder, import cylinder, and then create a pyproject 2ml with the following contents. This is where it gets a little bit heavy. So let me open the tree right now. Open folder. In this case, we're going to desktop. Yep. And so at the moment, we have a cqlib directory. We have a source directory, which has its own cqlib directory. We have our init py, and we have our cylinder. So the next bit is we're going to make the pyproject.toml. That'll look great. Okay. And then we need to define the contents of it. So I'm just going to grab this for right now, and then we can talk about what that means. All right. So we have the build system, which is saying what version of setup tools are required, kind of this back end. So this is boilerplate. We have the reference of what we're going to call the library. This is where the name matters. So when we're going to be doing the imports, when it's going down the default pathing to resolve this guy out, name this the name of your package. The version number, I'm using semver versioning. What is semver versioning? It's major, what is it? So this is major release. So these are the first one. These are breaking API changes, new APIs that are not backwards compatible. This is new additions that aren't backwards compatible breaking. So this is supporting all the existing APIs. And then this one is bug fixes / security fixes, super minor. And so the idea is, when you go to your major release, you go to 1. When you go to the next major release, you go to 2. And if you add new features during your current release cycle, you up these to whatever you need them to be, depending upon. So this is major release, new features, bugs, effectively. And you can look that up on the wikis. Maybe I should just have a version for that, but should be on Wikipedia too. Let's see. Yeah, software version. And they'll talk about all the different formats. Major, minor patch. There we go. Easy peasy. Okay. The author, fill that out with your information, whatever you need. And this stuff's kind of optional. The whole reason for this being as verbose as it is, the script. So this is a boilerplate script for making a Python package. The whole reason why a lot of this stuff is in here is for PyPy explicitly. So the kind of stuff that PyPy is looking for, if you potentially want to get your package up on here, this is the kind of stuff you'd need, right? So where would the author stuff show up? This is all meta information for filling out this side pane, right? Um, so a description, a little brief blurb about your description, the reference to the README. So as a good steward, you should have a README.md in your project for yourself and for anyone else if potentially you ever want to publish it. But it's just a good handy thing to have. The license is a reference to the license file, which we're gonna make one today for the sake of this demo. For your own projects, you probably don't need to have that. In this case, we're defining what version of Python is required. And then these are the classifiers for PyPy. So in this case, the programming language, the license, for the sake of the projects I've been doing them under the Apache software license, which is what CadQuery and CQ Editor are both licensed under. So I wanted something that would be compatible with their license scheme. Um, the tricky bit is that these strings are very explicit. So if you don't know what to put here, probably just clear it out. Or look up directly what string you do need. These are very verbose. These aren't free-form text entries. Operating system, OS independent, and now we get into the core bit. So dependencies. In the case of our lib project, we're not going to be dependent on probably CQ but I put this in here as a reference. So the dependencies I have listed are CadQuery. That's kind of self-explanatory. The specific version of CadQuery, and then the next one I have in here is CQ which is the library we just looked at, the Justin SDK library. I put that in here as reference to show you how you could import something that isn't coming off of pip. So in this case, the CQ we're saying at the source is get, and then the HTTPS github.com. We don't actually need this for the sake of this demo, but I wanted to give you some flavor text for what that would look like if you're getting from an outside source, right? And so what this does is when we go to install this library on the virtual environment or your regular environment, it'll make sure that these are installed correctly and at the version you need them at for the pip freeze, the references of installed packages. You can actually get by without this. You don't have to have it, but it's handy for, especially if you're going to put it up on GitHub or something like that. Um, Project URLs, again, this is boilerplate for PipPip. So we have the, for PyPy, we have the home page and we have a reference to the bug tracker. You don't have to have these, but again, if you, the whole point of this is I want to see the ecosystem thrive for CadQuery. So this is a good starting boilerplate to get your project ready for going out into the wild, right? So this will get your code up on, your package built and up on GitHub, and then if you want to go further and go off to PyPy, this is a good starting point. Okay, so we have a Py project. We're going to create a README.md just because it's good practice to do. And this is Markdown. So this is our README for CQLib. Okay, so here we go. This is our README for CQLib. And then the next step is we're going to make a license. It's easier to do it in your editors. If you try to create the license here in the root directory, Windows will complain. So if I make, there's a way to do it, but it's dumb. So if I make license, it's going to complain. Actually allowed it. Ha! Windows has gotten better about that. It used to be like Windows 10, stuff like that. Like it would throw a fit about that, and not make it because it doesn't have an extension. By the way, if you're using Windows, I highly recommend that you set up showing extensions by default. But you know, that is what it is. All right, so we're gonna grab. We'll just say, in this case, I don't know how far I'm gonna go with this now. I'm gonna grab a license. How's that? Um, and I'm gonna shamelessly steal it from my other project. Start. Effectively, you can not have a license, leave it empty, but for the sake of this demo, we're gonna go through the steps. Where do we look it up? Is that the document? That's how you apply it. There it is. Where's the plain text version? I think I just grabbed it probably from CadQuery. Yeah, that's it. Um, okay, we'll short circuit it. I'm gonna cheat today. So, home, MIDI, CadQuery helper. Okay, I'm just gonna grab this license, take it over to my license, paste it. And in theory, when I'm doing the cylinder code, I should copy the license up into here. So I should have my copyright notice and then the license directly here. But we will get there. Okay. So we have a license code. We're going to initialize. So this is for the sake of versioning. So now you have your code. In theory, it's testable. We're going to initialize this code. I'm going to come here, open a command line, get init. That creates our hidden Git directory. We're going to say get add, so that's going to stage all the files. So if I write get status, here's the stuff that's not in staging at the moment. Get add dot, that's just going to say add everything that's in the current directory. Get status. Good enough. And then git commit to initialize commit our stage changes. Okay, so now we have it, and then uh, install the package locally. So before I do that, I'm going to go on to my work on environment. In this case, I'm going to say work on CQ. Uh, we'll do this a couple different ways. So MK virtual. Before we get there, what do I have out here? Whole bunch of crap. Uh, let's say MK virtual env uh, custom lib. So we're going to make a virtual environment called custom lib. Okay. And then if I do a pip freeze, there's nothing installed. So now I'm going to say from the directory, so from this directory, we're going to say pip install front slash. And so what this should do is pick up the pyproject.toml, find the requirements that it has, install those requirements, and then set up this package on this custom lib work environment. So let's see if this blows up. All right, so it's installing a bunch of stuff. And then let's do a pip freeze. So you'll see some cool stuff in here. So you'll see CQLib is coming from the local file system, and then CQMore in this case is coming from Git. And then the rest of these are actually all packages coming off of PyPy. So we can look it up. So like multi-method. I have no idea what multi-method is, but it'll give you an example. There you go. So there's multi-method, and then you can read about it, tell you where to get it, tell you some examples of what it does. That's the whole point of the Python packaging. And a differentiator from like some other CAD languages, right? Okay, so this is installed, and so this is usable, so we can start calling this. So if I could go to Python, we can say from CQLib, import cylinder. In theory, that should work. Yeah, and then we can invoke it. So we can say cylinder parentheses, and that should work. So I should be able to say, let me get the other one going. What's the import? This will be a weird demo because I'm trying to use the REPL. This is the Python kind of command line runner. Um, yeah, let's do something weird. So I need the other code. Let's look at examples of this stuff. Shape. So let's grab CQ. Yeah. So we'll just import CQ. Import CadQuery as CQ. Yep. And then we're going to make our part. So results equals cylinder parentheses. Did that work? So in theory, that should be out there. And then if I call the exporter, so CQ exporters export, in this case it's not part, it's results. The out directory hasn't been made yet, so let's not worry about that. Let's say cylinder.stl. We'll run it. So we just ran it. Here's our cylinder.stl. The whole reason why this worked is because we're in the directory at the moment. So show in folder, well, not the whole reason, but the reason why I wrote to where it's wrote is wherever you're calling the script from, Python works off the current working directory. So because this was started uh, in our custom lib directory, the current working directory is inside of here. So I'm going to open this guy, and there's our file just coming off the Python REPL, and that's cool. Um, so that's under that working environment. And let me do a quit. And we'll go to a different working environment, a CQ editor. This is the one that I have. This is the working environment for where I have CQ editor installed. And we'll say pip install front slash, so install it again, but underneath my CQ editor working environment. And this is a very good reason why having the virtual environment wrapper is handy, because you could have an in development local copy of your library, running on running, and then on some other work environment, have your PyPy version of it or your Git version of it, your stable code. So you could have your stable code, your staging code, and your in development code. Like you could have multiple phases of this stuff. Okay, so now if I look at pip freeze, this should have cqlib in the list of references. Yeah, so now in CQ editor, I don't really have to even do much. So we'll say results equals cylinder, and I should put an equals in there. That would be helpful. So result equals cylinder, and then show object. And I should be able to say cylinder. And that's if I didn't type it in wrong. Oh, that's because it's not cylinder. It's result. That's better. So there you go. Okay, so now you could take this, you could dump it up on GitHub. And what am I running for time? Yeah, that's long enough. Next stage is you can dump it off on GitHub, and you could do these installations directly from GitHub. You don't have to install it locally, but for the sake of making changes, this is super cool. So to give you an example, like I need to do more examples. Um, let's go to here. Let's change it from cylinder to box arbitrarily. So now I have that changed, and I think it takes a third value. We'll put in 10. Box is like width, length, and height. Um, so I'm just faking it for today. Where is my stuff? So CQ editor. So we'll do a pip install front slash. Now, and so that's the tricky bit. If you are working off a library, especially a local library, any changes you make, so like we just saved this file. If I go and run it, the change won't take right away because it's still locked up in whatever's installed on the pip environment, on the work environment. So in order to apply your changes, there is a build step. So if I run pip install front slash, that'll redo the build. Everything should be cached. Should go fairly quick. Now, if I run my cylinder code, instead of making a cylinder, it's going to make a box because we changed out the source code. Okay. So that's the only kind of tricky bit you should be aware of is these aren't, when you make changes to your code, it's not applied until you do the build, if you're going this route. Now you can certainly probably find other ways to import your code and other ways to do this, but this is a very straightforward way to get your imports going. um, for your code pieces. Okay, so hopefully you learned a few things about Python packaging, and then being able to reuse your code